everyone, and welcome to another episode of Interstigation. In today's episode of Interstigation, we'll tackle another thing that is quite easy to do and simple to do, that you will likely to be able to do it by yourself after we go over the sine derivative and cosine derivative. And the thing is the tangent derivative. But before that, we need to make sure that we mastered our sine derivative and cosine derivative skills so that we can eventually get it to basically every trigonometric function. And let's get started with the daily problem to do so. So the problem asks us to find the derivative of this weird stuff. And if we look at it, this stuff is actually composed of two parts, the inside function and the outside function. And the inside function is a product of two trigonometric functions. So what we have to use over here is the chain rule and the product rule for the inside. So let's get started by just trying to do the chain rule. So what we have, it asks us to find the derivative with respect of x of sine of cosine of x, sine of x, like this. And if we want to take the derivative of that, we need to use the chain rule over here. So that would be equal to, so basic derivative, so cosine of x times sine of x. So like this. And multiply by, do not forget this part, the derivative of the inside. So cosine x. So cosine x, sine x. So that's the derivative of inside. And what we have over here is the cosine of sine. And you really don't have a clean way to simplify this, so we can just leave it like that. So we are satisfied with this part of our solution. We can just leave it like that. So let's just copy it and paste it over here. Exactly the same thing. And the other part, however, we can simplify that. So we need to take the derivative of this thing. If we want to take the derivative of this thing, the product rule tells us. So we want this differentiated times this not differentiated. So this differentiated, so that will be this first part. So that will be negative sine of x times sine of x. And the other part would be plus this sine of x derivative, so that's cosine of x, and that would be equal to cosine of x times cosine of x. And overall, that would simply simplify to, so we have this, the cosine of x sine of x times cosine squared of x minus sine squared of x. And obviously you can write this as a product of sine of x plus cosine of x minus sine of x, but it's really not needed over here. We just need to differentiate this function, and after we get rid of all of the differentiation signs, we are done. So this is our final solution. And let's take a look at our tangent derivative over here. So we have tangent derivative. So the tangent derivative, you guessed it, it wants to calculate the derivative of tangent of x. And if you want to take an intuitive feel about it, yes. So the tangent function looks sort of like this. So looks about like this. Kind of like a cubic function, but it's not exactly, because it has a lot of asymptotes. Something like this. So obviously, as we start, it is not a huge number. So at the origin, it's not a huge number, and as it gets bigger, it approaches infinity. And let's take a look. How can we do this using basic trigonometric identities and what we derived yesterday and the day before? So the sine derivative and the cosine derivative. What we have over here is we can simplify tangent of x as, so that will be sine of x over cosine of x. That's just basic trigonometric identity, and if we have that, we can use the quotient rule over here. So the quotient rule just give us, we have is, let's say f of x is sine of x, then f prime of x is simply equal to cosine of x, and g of x is equal to cosine of x, then g prime of x is equal to negative sine of x. And we want this subtract this. So what we have over here is actually equal to, so this this red part, so that would be cosine squared of x. Subtract this blue part, so that will be subtract sine of x, negative sine of x, and all over this g of x squared, so cosine of x squared. And do not see, oh, we have cosine of x, we can just plug it out, but it will be actually a lot nicer if you don't do that. So if you just continue to do that, so that will be cosine squared of x plus sine squared of x over cosine squared of x, and we can see that this thing over here is just equal to 1. So what we have over here is simply equal to 1 over cosine squared of x. And if you prefer it, I will write it as secant square of x, but I really do prefer this cosine of x representation of the tangent, the derivative of tangent, because it looks a lot cleaner to me, and it shows that when cosine squared of x is equal to 0, this is undefined, which means that we have an asymptote over here that cannot be reached. Thank you for watching this episode of Interstigation, and I will see you in the next one, where we go over 3 different rules for the first time, and these are all of the we don't use a lot trigonometric functions, which includes cotangent, secant, and cosecant. See you next time.